Gasoline direct-injected engines, also known as GDI engines, are the next generation of fuel injection. The difference is simple. Instead of mixing air and fuel inside the induction port above the valve, fuel is injected directly into the combustion chamber for more power and higher efficiency. The GDI engine can consume up to 35% less fuel, produce 20% fewer emissions, and increase power by 10% over traditional port fuel injected engines. When traditional port-injected engines collect carbon on valves, fuel system cleaners like BG44K will remove carbon from fuel system surfaces wherever fuel travels. Fuel injectors in a GDI engine point directly into the combustion chamber, so a fuel cleaner doesn't reach the intake valves. But unfortunately, carbon generated by combustion blowback from recirculated crankcase ventilation gases accumulates onto intake walls, reaches the valves, and clogs the air intake ports. The main purpose of the air induction system is to be the lungs of the engine and provide the exact amount of air to the combustion process. Air induction is also affected by the emission control system's recirculation of gases from the oil vapors from the PCV valve, unburned fuel in the form of fumes from the combustion chamber, and exhaust gases from the EGR. All recirculate back into the air intake to be burned the second time to lower harmful emissions. Deposits also form in the manifold and intake ports when valves, that remain open after the engine shuts off, leak exhaust gases back up through the air intake ports and into the manifold. Over time, these recirculated gases introduce sticky deposits that accumulate on the air intake. This constricts the amount of air entering the combustion chamber, disrupting the critical air-to-fuel ratio used by the manufacturer. This causes timing issues and misfires, which result in carbon buildup on valves, piston tops, spark plugs, the combustion chamber, and injector tips. The critical air-to-fuel ratio is once again affected when injectors clog and their fuel flow and spray pattern is reduced. Symptoms of car-killing deposits include poor fuel economy, power loss, hesitation during acceleration, rough idle, hard starting, pinging or knocking, and increased emissions. The technician uses a process utilizing an atomizing tool to clean the entire air induction system. A proprietary product, BG GDI Intake Valve Cleaner, part number 260M, effectively dissolves deposits and removes baked-on carbon on valve ports and injector tips while the engine is running. BG Fuel Injection and Combustion Chamber Cleaner part number 201M cleans injectors, the combustion chamber, and piston tops. It loosens deposits in GDI engines and burns them safely in the combustion process. Fuel quality and the amount of cleaning detergency in gasoline varies by location, and depending on the station varies in the amount of time fuel is in storage. Fuel system deposits form in the fuel tank, fuel pump, fuel filter, and fuel lines, the entire fuel injection system, the combustion chambers, the O2 sensors, and the catalytic converter. Deposits in all these areas are cleaned to like-new condition using BG44K, especially baked-on deposits, cleaned within the next full tank of fuel between engine use during the cool-down process. The BG air induction and fuel injection services pay for themselves in lower fuel cost, higher engine efficiency, and longer life. This service should be performed every 10,000 kilometers. BG Products Incorporated, an international company founded in 1971 in the USA, pioneered the products, equipment, and services used in shops around the world to keep engines running clean for life. between every service. For more information, contact your BG Middle East representative.
BG